I'm continuing where our previous video left off. So we were finding the y-coordinate of our vertex. So if my arithmetic was right here, and you can fix it, by the way, if I make any arithmetic mistakes. So we find out that when x is 3, the y-coordinate is -4. So this is the coordinates of the vertex of our parabola. So we've got all the information that we need to sketch the parabola. So we know that we've got a vertex at 3, -4. I'm going to slide my axis over a little bit here. And we know our value of a is +1, so our parabola opens up. We know our y-intercept is at 5, so that is enough to give us a good shape for our parabola. I want it to go right through that point and have a smooth turning point here. And then the only thing I haven't listed yet is our axis of symmetry. Our axis of symmetry would be x equals 3. It passes right through the vertex. And then we can check out whether it looks like, I'm not doing this on graph paper, but do our x-intercepts appear to be at 1 and at 5? So our graph, even though my paper isn't perfect, looks close enough. There are additional examples of graphing parabolas in your textbook, so if you need more practice. And of course, we'll discuss your homework examples in future class days. All right, let's continue on then. If we have a quadratic equation in y, that means what if the x is to the first power, but the y is squared? Well, how would that change our parabola? It will turn our axis of symmetry horizontal. So a sideways parabola has y squared instead of x squared. So do we have to start learning everything about parabolas over again? Absolutely not. The difference is simply that we reverse our thinking for x and y. So if we look at this equation, instead of saying y is equal to, or f of x is another name for y. So here it doesn't say y is equal to x squared, it says x is equal to y squared. So what do we have to remember here? Everything that we did previously that was true for the x-coordinate is now true for the y-coordinate. So the opposite of b over 2a is how we will find the y-coordinate of the vertex. So here, if we do this formula first, since I wrote it first, you could do this in any order, but let's do the opposite of b would be -4, and 2 times a would be -4. So we know that the y-coordinate of our vertex is 1. And then how do we find the x-coordinate? To find the x-coordinate, we let y equal 1. We let y equal 1 in this equation. If we put 1 in here for y, we'll have -2 plus 4 minus 3. So it looks like our x-coordinate of our vertex will be -1, 1. So when we sketch the graph of this parabola, look at what we're going to know. Our a value is negative, so this parabola opens, but now instead of down, the negative side will be opens to the left. When it's sideways, positive is to the right and negative is to the left. And it will be narrower than ordinary. All right, so let's think of some other points we know here. An easy value would be our intercepts. So think what happens here if we let y equal 0. If we let y equal 0 in this equation, then x would be equal to -3. So now we know the vertex point and we know one of the intercepts. That alone should be enough for us to graph this parabola. So let's see what it looks like if we graph -1, 1 as our vertex, and we have an intercept at -3, 0, And we know this parabola opens to the left, so this parabola has a horizontal axis of symmetry through its vertex. So now our axis of symmetry is going to be y equals +1. So we use the y coordinate of the vertex for our axis of symmetry. So it takes a little bit of getting used to when we have a y squared, but remember that the formula we used for the x coordinate of the vertex now becomes the value of the y coordinate of the vertex. Oh, before I scroll here, I should come back to this box here on your summary sheet. Notice that this is the graphing form. So if I were given an equation, let me do an alternate. Let me use this space here. If we had an example like x is equal to 1/2 the quantity y plus 1 squared minus 7, the vertex of this parabola would be the opposite of 1 for the y coordinate. We're doing exactly what we were doing with x's, but now we have to do the opposite shift inside the function, and that's with the y coordinate. And then we do the same sign. This is a shift of the x, but it goes in the same direction. So you have to reverse your thinking. What was inside the parentheses we compensated for, and we shifted in the opposite direction. But outside the function, it shifted in the same direction. So this would be the vertex of such a parabola. And our a value is 1/2, so we would know that this parabola opens to the positive direction. So when y is the squared term, the positive direction would be opens to the right, to the positive side. And because it's 1/2, it would be wider near its vertex. So everything we did with the x squareds, now we're doing with the y squareds. So that's quite a bit to take in. So here's a little summary of those 4 different shapes of parabolas. So we'll give that a try with homework, but it might take us a couple of days of practice to make this easier for everyone.